Hi there, and welcome back to this Integrated Math 1 video series. In today's lesson, we're going to talk about something called systems of equations. But before we do that, let's go ahead and hop into our warm-up for today. Go ahead and try these three problems. All right, so in number one here, we've got this graph 3x minus 4y equals 24. So as we talked about in our last lesson, we can take this is called standard form, and we can find the x and y intercepts pretty quickly. Let's see, the y-intercept would be 24 divided by negative 4. If we were to solve for y there, it would be negative 6. So we have a y-intercept of negative 6, a 0 comma negative 6. And then of course the x-intercept would be 24 divided by 3, 8. So we would have an x-intercept of 8 comma 0. And so that kind of goes back to what we did in the last video. Once we plot those 2 points, from there we can connect those 2 points with a straight line, and that's going to form our linear function. All right, so number 2, create a linear equation with an x-intercept of negative 4 and a y-intercept of 7. There are an infinite number of answers to this. I'm going to give you one here. So let's see, we could do negative 4x, 7x minus 4y equals negative 28. Let's just check that and see. So the x-intercept would need to be negative 4. So when we do that, see negative 28 divided by 7 is negative 4. Y-intercept needed to be 7. Let's see, negative 28 divided by negative 4 is 7. So that's one of them. Let me show you just real quickly what another one could be. Really, if you multiplied the whole equation by any number, you could get a new equation that also has those same characteristics. So for example, if I multiply everything by 2, so 14x minus 8y equals negative 56 would have the same x and y intercepts. And you can check that by dividing. All right, number 3, is the point 3,5 a solution to the equation? So we've got this equation here. Is 3, 5, that point, a solution to that equation? Well, to make sure that it is, we need to actually substitute those values in for x and y and see if we get a true statement. If we get a true statement, then it is a solution to the system. So let's go ahead and substitute 3 in for the x and 5 in for the y. So we're going to get 5 equals 4 times 3 minus 7. Let's see if this is equal. Well, let's see, left side's always going to be 5. See, 4 times 3 is 12 minus 7. And 12 minus 7 is 5. That is a true statement. So because those are indeed equal, 3, 5 is a solution to this equation. So we just need to substitute those values in and see if it works out. That's the best way to check and see if it's a solution. Graphically, what that means is, if we were to graph this line here, 3, 5, the point 3, 5 would be a point on that line. I think we've talked about that in a previous video. But 3, 5 is on that line. All right? So let's go on to our goal for today. We have 3 goals. The first one is to be able to write a system of equations. Most of the time it's going to be from a real world context. Solve a system of equations graphically, and then understand what the solution to a system of equations means. And I know this is a new idea, so let's go ahead and talk about what a system of equations is and what that means through this example that I have for you. All right, so let's go ahead and dive into our example to get started off here. This is the same kind of situation that we dealt with in our last video with Heather and coins in her purse. The only difference now is we're looking with nickels and pennies instead of nickels and dimes as we did last video. So she's got nickels and pennies in her purse. She has a total of 9 coins. Write and graph an equation that relates the number of nickels and the number of pennies. So let's go ahead and define our variables. You could use n and p. I'm just going to go ahead and use x and y because I'm going to define them, and then also because in Desmos we can only use x's and y's. So x equals, I'm going to say the number of nickels, and y is the number of pennies. Okay? So if we have 9 total coins, some of them are nickels, some of them are pennies, we would add them up, right? If we have 9 coins, that should be equal to the number of nickels plus the number of pennies. So that's our first equation that we're going to work with, and we're going to go ahead and graph this. So the y-intercept would be 9, and the x-intercept would be 9. Going back to our last video, when we substitute y in or 0 in for x, we get the y-intercept. When we substitute 0 in for y, we get the x-intercept. So if we go ahead and graph these, they both should have an x-intercept of 9, which makes sense because if we have 9 of one type of coin, that would mean that there's 0 of the other. So if we go 1, 2, 3, 4, 5, 6, 7, 8, 9 in the y, 1, 2, 3, 4, 5, 6, 7, 8, 9 along the x. Then of course from there we can connect the two and see what we have here. Of course, this is going to extend out forever in both directions. However, it's only really the first quadrant that makes a whole lot of sense in this example. So we could have, so if this is nickels, the number of nickels, and this is the number of pennies, we could have 0, so this is 0, 9, so we could have 0 nickels and 9 pennies. We could have, so this is going to be other points here along the way. Of course, we can't have fractions of coins. So you could have like 1, 2, 3, 4, 5, 6 nickels and 3 pennies. That would still make up 9 coins altogether. So this maps out and graphs all the different possibilities that we could have in this scenario that would still satisfy the constraint of having 9 coins. All right, so we've written our equation up here at the top. We've graphed it to relate the two. Let's go on to our second part of this. So it says Heather has nickels and pennies in her purse. Let's pretend this is a separate situation. She's got a whole different set of pennies and nickels. If you want to think about it that way for a moment. She has a total of 25 cents, all right? Write and graph an equation that relates the number of nickels and the number of pennies. So now we don't know how many coins, but we know how much they're worth. So we're going to look at the same thing here. X is nickels, number of nickels, and Y is the number of pennies. So we have 25 cents. And that should be equal to the total value of our nickels plus the total value of our pennies. So the total value of our nickels is the number of nickels. Each nickel is worth 5 cents, right? So if we multiply the number of nickels times 0.05, because it's 5/100ths of a dollar. If we multiply those together, this is going to give us the total value of all of the nickels plus 0.01 times y, because it's 1/100th of a dollar is the value of 1 penny. And so together, if we add those together, we should get the total value of the coins in her purse, which is 0.25 or 25 cents. So if we go to graph this, well, let's see. If we divide 0.25 by 0.01, that's 1/100th, would be 25. So we're going to get a y-intercept of 25. So let's just go 0, 25. Whereas the x-intercept is going to be 5. 0.25 divided by 0.05 is going to be 5. So 5, 0. All right, so let's go ahead and graph this. So we have 5, 0, 1, 2, 3, 4, 5, and then up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, go all the way up to 25. And this graph is not going to be perfect. Let's just go ahead and go up maybe by 5 in our y. So the scale's 5. So 5, 10, 15, 20, 25. So we can just go ahead and do that. And just know that we're going up by 5 in our y's. Let me redo that, make sure it's a little bit better here. There we go. All right, and then we can put arrows to extend it out forever in both directions. And so this is the relationship between the number of nickels and the number of pennies, with each point on here representing the set of pennies and nickels that adds up to 25 cents. And so this point right here is 1, 2, 3, 4, 5. So 4, 5. This one here is 1, 2, 3, 2. 3, 10. 3, 10. So let's see if that works out here. So it'll be 3 nickels and 10 pennies. Does that add up to 25 cents? It does, doesn't it? We could also have, this is 2.15. We could have 2 nickels and 15 pennies, and that would still work. Here would be 1, 20. So it'd be 1 nickel, 20 pennies. And of course, here's 5 nickels, 0 pennies. Here is 0 nickels and 25 pennies, all adding up to 25 cents. All right, so the question here is, now that we've done both of these, is what if we combined them? What if we said, not only do they have to add up to 25 cents, but we also have to have exactly 9 coins. Is there a scenario in which both of those are satisfied? Both of those constraints are satisfied? Well, let's see. So we've graphed this one. Let's go ahead and graph the other one as well here. It had, let's see, an x-intercept here and a y-intercept of 9. So if we put 9 here, let's graph it on the same scenario here. So 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then up 9, so this is 5 and 10, so 9 would be like right below that here. And what happens if we connect these? Okay. So the black line signifies all scenarios in which we add up 25 cents. The red line are all the points satisfying 9 coins. Are there any points that satisfy both? And you're probably saying yes. The point in which they intersect, which my graphs are not perfect here, but the point right here, which is 4, 5. 4 nickels and 5 pennies. 4 nickels and 5 pennies, that adds up to 9 coins, right? 4 nickels is 20 cents plus 5 pennies is 25 cents. So that's the one solution that satisfies both situations, 9 coins and 25 cents. And that's the key to this. That's the solution to our system, okay? There are an infinite number of solutions to this line here. Maybe not in the context, but there are an infinite number of points on this line. There are an infinite number of points on this line. But when we combine them together to create what's called a system of equations, there's only one solution in this scenario here. So there's one solution to this system, and it's whatever point works for both. All right, so let's continue on and look at some other examples here, see if we can solidify our understanding of this. So here is another system. There's no context. I've kind of stripped away the context, and let's just look at the scenario here in terms of these two in standard form. So we have 4x plus y equals -5, and x plus 4y equals 12. Let's go ahead and graph it and just do the best we can here to see what we can do. So in the first one, if we think about the y-intercept, if we cover up the x part, we're going to get y equals -5. So that's going to be our y-intercept. So y is -1, 2, 3, 4, 5. Okay? Our x-intercept, if we cover up the y, is going to be, let's see, if we were to solve for x here, we're going to get -5 divided by 4. -5 divided by 4. Well, let's see, -4 over 4 would be -1, right? This is a little bit more than that in terms of the negative direction. So it's a little bit less than -1. So maybe something like right here. All right, and then next we have, let's see, the x-intercept here would be, what, 12, right? 1, 2, 3, 4, 5, 6. Right there. And then the, and I'll do that in a different color, maybe blue. Okay, and then our y-intercept to cover up the x, again, we're just substituting 0 in for the x value there, is going to be, let's see, 12 divided by 4 is 3. So y-intercept 1, 2, and 3. So let's form our two lines here. So the first one might look something like that. And then our other one might look something like that. Okay? So take a second and see if you can maybe estimate what the solution is to the system. All right, so you might be saying here, the solution is maybe negative 2.1 and 3.2 or something like that. It's this point right here, right, that we're talking about. This point right here. So that might be, maybe if we were to guess, negative 2.1.1, comma, 3.2 or something like that. Might be our best estimation for that. Now, with graphing, sometimes, if our answer is not a nice integer value, it's kind of hard to tell exactly what the answer is. But let me show you how you can do that using Desmos. So if you type in the two equations, so I've got them typed in right here. So therefore, x plus y equals negative 5, x plus 4y equals 12. And Desmos is nice because if you just click on the intersection, it tells you what the values are. So we were pretty close. Negative 2. We said 0.1, and it's actually 0.133. And then the y is 3.533 instead of 3.2, I think is what we said. So we were close, but not exact. And so you can use Desmos or your TI-84 calculator to find those points of intersection. If you're on a TI-84 calculator, let me show you real quick how to do that. You can go to second calc. Once you have the value, the lines typed in, and hit, go down to 5 and hit intersect. And then cursor over to where you think they intersect and hit enter 3 times, and it'll do something similar like this, where it'll tell you those values at which they intersect. All right. I've also got the one that we did a minute ago, pennies and nickels. Number of nickels down here, number of pennies right there. And again, you can see that the solution there was 4 or 5. Okay, let's go back to our situation here and see. So it's not a perfect science. This whole idea of graphing, especially if the answers aren't integers, it's not a perfect science. But I want to give you a chance to try the last two for today. So take a moment and read the situation and see if you can figure out what is the solution. So this one, we're not actually given a question, but we might be interested in when are these two plans equivalent? When are we going to be charged the same amount? So see if you can figure that out. Okay, so in the first one, AT&T offers a plan monthly fee of $25, so that's not going to change. That's just a monthly fee, plus 10 cents per minute. So 0.1 x. We'll say x is the number of minutes, and it equals y. So that's for AT&T. For Track My Phone, they have a monthly fee of $15, and we're only talking about within 1 month, so we're not worried about additional $15 charges. That's just a one-time thing because we're only talking about 1 month. Plus the per minute charge, which is 0.15 per minute, so times x. So those are our two. Now notice these are both in what we call slope-intercept form. So it's okay, that's fine. You can have things in slope-intercept form. They're not always going to be in standard form, and that's okay. So sometimes you might see like a system of equations with like a curly brace around it, just to say that like these two equations are coming together. We're looking for the solution of both of these, that kind of thing. So if we were to graph this, you might start with a y-intercept and then use your slope. I'm going to show you on Desmos what you can do with this. So let's just type these in. So 0.1 plus 25. And the other one was y equals 0.15 x plus 15. Yeah. Okay, so I'm going to zoom out here. X-axis is minutes, y-axis is cost. So if I zoom out here, so starting out, if we just use like, a few minutes, the whole minute charge is not going to really impact a whole lot. So the lower monthly fee is going to be best. But if I use a lot of minutes, so if I just continue to zoom out here, so where do they intersect? We got to scroll over here, and it looks at 200,45. 200,45. So if I use the phone for exactly 200 minutes, I would pay the same amount on both with both companies, and that amount would be $45. That's where that comes in. So the Y value is the amount that they're equal at, and then 200 is the minutes that would put us at the same amount of money. And so you could graph them and see here pretty clearly where they intersect. So if I use less than 200 minutes, I'm going to use the second one here. I think Track My Phone. If I use more than 200 minutes, then I'm going to go with AT&Me, because look, the green line is below the blue line at that point. Thinking back to our systems of our solving linear inequalities a few sessions ago. And so you can use this to make decisions about when, what's best for you. If you typically use a lot of minutes, then maybe you'll go AT&Me. If you use less minutes, then go with Track My Phone. And so this allows us to make better decisions in our daily lives. All right, up next, our last one here is talking about a movie theater and buying different items from the movie theater. So take a few minutes and see if you can try those. All right, so in this case, we got John and friends bought 4 bags of popcorn and 3 sodas at a movie for a total of $13.50. So we're talking about total cost of those purchases. So if we think about 4 bags of popcorn, so I'll say X is the bags of popcorn. So bags of popcorn. You always want to define your variables so that people know what you're talking about there. Plus 3 Y, which is the number of sodas purchased, equals, so let's see, 4X, again, $4 times however many popcorns I buy here. That's going to give us the total amount that we've spent on popcorn, plus 3 times the number of sodas we bought. That's going to give us the total amount spent on sodas. Add those together, and you should get the total price, which is $13.50. All right, and then below that, we'll do the second time that they went. They bought 2 bags of popcorn, so 2X, plus 5 sodas, so it'll be 5Y, equals a total of $12. So you always wanted to think about, what do you have the value of? In this case, we have the value of the total cost. So that's what we're going to think about in terms of. Sometimes you just have the total number of things, so you just add them up. You're really going to think about what you have. So it says, how much will John and his friends pay in dollars for 5 bags of popcorn? So 5X plus 2 sodas. How much is that? That's what we want to know. So there are multiple ways to do this, but probably the best way is just to find out how much is 1 bag of popcorn and how much is 1 soda, and then we can substitute those in there and see how much 5 bags of popcorn and 2 sodas are. So let's go ahead and graph these two and see what we get. So 4X plus 3Y equals 13.5. 4x plus 3y equals 13.5, and 2x plus 5y equals 12. Let's zoom in here. All right, so this blue one, sorry, the green one, the green one is all the numbers of different popcorns and soda combinations that cost $13.50. The purple one is the line that represents all the various combinations of popcorn and sodas that cost $12. And so we want to think through, you know, and that, by the way, that's given the number of bags and sodas that they bought. So what is the solution to both of these? Because, you know, regardless if they walk in the first trip, second trip, the cost for popcorn remains the same, right? The cost for sodas remains the same. So we don't know the cost of popcorn and sodas, but we can figure it out because we can find the solution to these two and see where they intersect. So if we click on that intersection here, 225 and 150. So X being 225, let's see, X was the number of, or the cost for a bag of popcorn, right? And 1.5 was the cost for the sodas. So, and I think I misspoke earlier. When I defined X here and Y, X is the cost for popcorn and Y is the cost for a soda. Because the 4 and 3 are the number of those that I purchased. Sorry about that. All right, so again, a bag of popcorn costs $2.25, a soda costs $1.50. Again, we're looking at the solution here and where they intersect. And just to kind of walk through real quick, when you have two or more lines, an equation is called a system of linear equations, and we're looking at the intersection of those two, and that's our solution. All right, if we have something like this, you know, you have one solution here, the point -1, -1. Does this one have a solution? Will they eventually intersect even though we can't see it? Yes, they will, right? So yes, this does have a solution. How about number 10 here? How about these? These are parallel, right? Are these ever going to intersect? No, right? So there is no solution to this system. And in fact, if we go back here, if the slopes are the same, but the y-intercepts are different, then there's no solution. All right, they're never going to intersect. We're never going to have a value that satisfies both at the same time. All right, so hopefully that achieves our goal for today, which was to write a system of equations. You know, given a real-world context, we did that a number of times. Solve a system of equations graphically, going back to, you know, just finding the point of intersection between the two lines after we graph them. And then lastly, understanding what the solution of the system means. It's the set of x and y that satisfy both situations at the same time. All right, so in our next video, we're going to talk about how to do this algebraically. We've looked at graphically today, and in most cases, you know, we can do it if the answers are integers, but what if they're not? Like I said earlier, it's not a perfect science. We can't find those fraction of values or decimal values very easily. But in our next video, we're going to talk about how to do it algebraically, in which we can be more precise in finding those solutions that are not integer values. So hopefully you'll join us then to find out how to do that.